Okay, we're going to continue our discussion about writing reactions, and in this vodcast we're going to take a much closer look at single replacement reactions. Not only are we going to determine what the reaction is, we're going to determine if the reaction happens. The idea is, let's say you had sodium reacting with lithium chloride to form sodium chloride plus lithium. Even though you can write this reaction, obviously, that doesn't necessarily mean that in real life, if you took some sodium and lithium chloride, that this reaction would take place. So what we're going to do is come up with a technique to determine if that reaction happens. Okay, the one thing you need to have handy is an activity series. On the Moodle site, there's a PDF with an activity series present. You're going to want to either have that available on your screen or print it out so you can use that when you're trying to write these reactions. So there's two things you want to be able to do with a reaction. First of all, write the balanced equation, and then second of all, determine if that reaction happens. So let's write the reaction for this sentence first. And you want to be good at writing formulas because this is how usually you'll see the questions. In other words, they'll be in word form, not in formula form. So you want to be proficient at writing reactions. So calcium is not diatomic, so we don't put a subscript there. It's reacting with lithium chloride. Now you should notice you've got lithium, which is Li, and you've got chloride, IDE ending, so it's not a polyatomic. So we have the element chlorine. Lithium is 1 plus, chloride is 1 minus. So when we write that formula, it's LiCl. Now we're not going to worry about the subscripts for states right now. We'll worry about that a little bit later. Okay, as we said with single replacement reactions, metals replace metals, nonmetals replace nonmetals. So calcium is a metal, so it's going to replace the metal in the compound. Remember, metals form cations, and in a formula we always write the cation first, the anion second. So calcium will replace lithium, form a compound with chloride, so calcium chloride. Calcium is 2 plus, chlorine is 1 minus, so our formula is CaCl2. Now all of that should be review. And again, if you're not proficient with writing formulas, you need to be. So go back and practice. Then the lithium, after it gets kicked off on its own, you just write it like that. Now if you were going to balance this, we would go through and we would need a 2 there and a 2 there, and it would be balanced. Alright, now to determine if this reaction happens, we need to use what's called an activity series. So let me write that reaction again. We had calcium reacting with lithium chloride to form calcium chloride plus lithium. The way you use an activity series is the elements are listed in order of activity. In other words, the ones at the top have more activity than the ones at the bottom. As you can see, decreasing activity moving downward. The thing that's doing the replacing, in other words, calcium here is trying to replace lithium. For this reaction to happen, the thing doing the replacing has to be higher on the activity series than the thing it's replacing. So for us, we have calcium there, but lithium is up there. So even though we can write this reaction out, the calcium is lower than lithium, so this reaction we would write NR, which stands for no reaction. So in real life, if you put calcium with lithium chloride, that reaction is not going to take place. Okay, let's take a look at a number of examples. Let's take a look at the first one. We've got iron reacting with copper 2 chloride. Remember, copper here has to have a 2 plus charge because of that subscript, so it's copper 2 chloride. Now iron, let's just assume that it's 3 plus, and you would need to be told what that charge was because it's a transition metal. So the products, iron's a metal, so it's going to replace the metal. since it's 3 plus, we've got iron 3 chloride, and then the copper is on its own. Copper is not a diatomic, so we write it like by itself. I'm not going to balance these equations because you should be proficient with balancing. If you're not, again, go back and practice. Alright, now we want to see, is iron higher than copper on the activity series? Iron is here, and copper is here. So iron is higher than copper on the activity series, so that reaction would happen. So we've put a check mark there. Alright, let's take a look at the next one. Let's assume mercury here is 2 plus. So we would have mercury or mercuric sulfate and tin. Now again, I'm not going to bother balancing these. However, the formulas are right, so you want to double check that you know how to write these formulas. Is mercury higher than tin on the activity series? Mercury is there, tin is up there, so mercury is below, so that one would be no reaction. Let's take a look at the next one. Barium is going to replace nickel. Barium is 2 plus because it's in the second column. Phosphate plus the nickel. Now what you're going to see is that barium is not on our list. So we wouldn't be able to determine from this list if this reaction happens. So we'll just assume it does happen. We've got lead, which again, let's assume it's 3 plus, reacting with gold nitrate. So we have lead nitrate plus gold. Gold is at the bottom. Lead is right there. So that reaction takes place. So we'll put a check there. Lithium is going to replace hydrogen. Lithium is 1 plus. Hydroxide is 1 minus. Now remember, that's the polyatomic. And then we've got hydrogen on its own. Lithium's at the top of the scale. Hydrogen is there, so that reaction happens. The next one, we've got potassium chloride plus silver. Potassium is way up at the top. Silver is towards the bottom, so that reaction happens. Calcium and sodium hydroxide. So we've got calcium hydroxide. Remember, hydroxide is 1 minus. And sodium. So we want to see, is calcium higher than sodium? Calcium is there. Sodium's right below it. So yes, that reaction would happen. Copper, let's assume it's 2 plus. Iron, as you can see from the formula here, iron is 3 plus. So we have copper, 2 hydroxide plus iron. And as we said from up here, iron is higher than copper, so that reaction would not happen. Down here, again, let's assume iron is 3 plus. So we have iron 3 hydroxide plus copper. And as we said from the first reaction, iron is higher than copper, so that reaction happens. Okay, so what you want to do is make sure when writing single replacement reactions that you can write the reaction, but then you can also determine if the reaction happens using that activity series.